Hello. Hello, class. Sorry I'm missing today. I chose this lesson because since I'm missing, hopefully this is a bit of a review and shouldn't be that hard. This is composite functions. We've actually already done a little bit. This is just kind of a review of it, maybe a little bit of an extension, but not much. Hopefully you kind of remember this f of g and this sort of general form. Any case, let's just do number one together. I think you'll be able to follow along. So number one, it just says f plus g. That's pretty easy. You take whatever f is, which is 2x minus 5, and then you add to it g, 2 minus x, and you get your result here, which is simply x minus 3. So there's your answer there. That's pretty simple. One that you might not remember, f of g of x. Basically what you do is you start off with f of x, but in place of x, just put a parentheses. And in that place, this used to be what x is, but now we're going to put g of x there. So all of g of x goes there. In which case, 4 minus 2x minus 5, negative 2x minus 1, and here's our final answer. Plugging things in is relatively easy here, so we're going to do number 5. This is just g divided by f, so g, but instead of x, I put in 2. And in general, I use parentheses whenever I see an x and I'm substituting in, just because parentheses will you're never going to have too many parentheses. You might have too few, in which case you'd be wrong, but yeah, you'll never have too many. 0 divided by negative 1 is just 0, though. So there's our answer. So hopefully you can do the rest of those. Moving on. Let's check out some, let's see. Yeah, we should probably do one of these here. Maybe number 10 here. So kind of mess with some exponentials. So again, f of g. So f is just simply something to the 2/3, but we're going to put g in there. And as you know, exponent to an exponent, we can multiply. This just becomes x to the 4th. All right, what about domain and range? Hopefully you remember domain and range. Domain is all the values that x can be. The things that you have to remember about what x can be is basically like you can't take the square root of a negative number, right? You can't divide by 0. Those are the main things. So let's see here. I'm not going to reduce, and the reason I'm not going to reduce is because it kind of loses some information if I do. For example, number 13. Let's check out number 13. F, which is that. But I'm going to put that in there, right? I'm going to put g of x in there. So we got that. Now, if I reduce, the square root and the square would cancel, but I don't want the square root and the square to cancel because this actually has a restricted domain because I can't plug in anything for x. In fact, there's no way I can plug in any negative number. In fact, I can plug in 0 though, so it goes from 0 to infinity. Now, what about y? Well, square root of something squared, I understand what comes out of a square root, 0 to infinity. What comes out of a square, 0 to infinity. And so the range, when I add 1, goes from 1 to infinity. And again, bracket around 1 because we actually want to include it. Hopefully, yeah. So now try the reverse, g of f of x instead of f of g of x. Awesome. All right, let's go to the next page here. All right, this is kind of interesting and new for you. This thing right here, f inverse. The inverse function is inverse in the sense that what's inverse of division? Well, it's multiplication. So even though it looks like I'm taking the function to the power of -1, that is not what's actually happening. This is just a special symbol that says this is a function that's the inverse of function. So it's going to reverse everything. Everything that the original function told you to do, this thing's going to reverse it. Now, how to find f inverse of x. Switch x and y, then solve for y. That's it. So it's pretty easy, really. So for this one, what I would do is I would write x equals 2y plus 15. subtract the 15, x minus 15 equals 2y, divide by 2, I'm going to get y equals x minus 15 divided by 2. And that's my inverse function, x minus 15 divided by 2. So here's my inverse function. One of the interesting things is if I take f of my f inverse function here, like so this composite function like this, what I'm going to get is, if you notice, I'm going to get 2 x plus 15, but instead of the x, I'm going to put in my inverse function. Now notice when I reduce this, the 2's cancel, and so I get x minus 15 plus 15, and then you notice, oh, well, that simply equals x, and that's always what's going to happen. So oops, that's a p. F of f inverse of x will always equal x, as will f inverse of f of x. So if you find the inverse function of f, in fact, the inverse of the inverse function of f is in fact the function of f. You might want to replay that sentence again, but it's relatively intuitive though. All right, let's find the domain and range here. In this case, the domain and range is really boring because these are both linear functions, and so I can plug anything in and I can get anything out. There you go. Let's do something that has a little bit more interest in it. We'll just do something simple like number 21 even. So I'm going to write x equals y squared plus 16. Then I'm going to say, well, x minus 16 equals y squared. So then I'm going to take the square root of x minus 16 equals y. So this is the square root of x minus 16. Now this one's going to be a little different here. The domain, in this case, well, the domain of your real function here, I can plug anything into x squared. And so the domain's going to be all reals. The range, though, the range is going to be from 16 to infinity because I only get positive numbers out of x squared, and then I'm going to add 16. So it's going to go from 16 up to infinity. The inverse function, well, notice I've got x minus 16. So x minus 16 has to be greater than or equal to 0. In other words, now what's the range? Well, the range is from 0 to infinity, because what comes out of a square root is from 0 to infinity. Notice that the range and the domain look kind of similar. In fact, they're exactly the same. And likewise, notice the domain, though, and the range of the function and the inverse function are not quite the same. They're similar, but they're not quite the same. That oftentimes is going to happen. They will almost perfectly switch, although there might be some addendums there. It might be a little bit different. Anyway, let's do one more together, though. Let's do number 23. Or actually, you know what? Let me see if I want to do something else. Because we did a square. Let's do let's do this one. I'm trying to think. Nah, square root's good. So here we go. Y equals the square root of 6 minus, x equals the square root of 6 minus x minus y. X squared equals the square root of 6. Yeah. Ooh, all right. I'm going to just start all over on this one. I got started, and then everything started to not. Okay, here we go. Switch the x and the y. X equals the square root of 6 minus y. Take the square root of the square of both sides. X squared equals 6 minus y. Subtract the 6. X squared minus 6 equals negative y. Divide the negative. 6 minus x squared equals y. 6 minus x squared is our inverse function. Domain, again, well, what do I know about my domain? I know that 6 minus x has to be greater than or equal to 0, in which case negative x must be greater than or equal to negative 6. But when I get rid of the negative, I got to flip the sign. So it's less than or equal to 6. So it's actually going to be from negative infinity up to 6. When you plug that in, it kind of makes sense. I mean, if I plug in 6, I get 0. Square root of 0 is 0. That's fine. If I go less than 6, like 5, which is in my interval, 5 is okay because 6 minus 5 is 1. Square root of 1 is 1. But if I plug in 7, not inside my interval, it doesn't work. So my interval is looking pretty good. The range, well, the only thing that can come out of a square root is positive numbers, including 0. Now, the domain, again, this is going to look somewhat familiar, but not perfect. Here, what's the domain? I can plug in anything. So that's different, right? The range was 0 to infinity. Now the domain is not. It's all reals. The domain in my original function here was negative infinity up to 6. And in fact, this is also going to be negative infinity. Oops. Up to 6. And the reason is, well, that goes from 0 to infinity. But then since you're subtracting it, it actually goes from 0 to negative infinity. But then you're adding the 6. And so you go up to 6, but still down to negative infinity. There you go. All right, so hopefully that helps. I'm going to also save the document to the answers onto the Canvas page, so you should be able to see that as well. Hopefully this was helpful, and I'll be there, and I actually might even make it there for Studium, so you can check in with me then. All right, thanks.